There we go. All right. Got it. All right. So what we know about our climate in Vermont, we know it's changing. And this is from long-term weather records we have mostly in Burlington, but it's a good indicator for how the rest of the state climate is changing as well. Of course, we have year-to-year variation in annual temperature and the total precipitation we get. The long-term trends are pretty striking in that we've seen an increase in average temperature, about 3 degrees over that time frame, and 9 inches increase in precipitation. And one of the changes that this is causing is a longer growing season. If you're a gardener or anything, you're aware of this. Also just recognizing we're often starting spring a little earlier and have really long fall conditions. And this is reflected in our growing season data. So we know that we've increased our growing season a few weeks. It really does depend on where you are in Vermont. Of course, we have a lot of differences based on, topography and location and aspect and things like that. But on average, we're seeing about 3 weeks increase in our growing season. And, this is actually not a bad thing for our trees and our forests. Our climate here in Vermont, we consider it temperature limited. That means really the growth is constrained by the shortness of our growing season. So as that growing season lengthens, there's more time for trees to grow, more time for them to do things to capture extra sunlight, make sugars and carbohydrates that they can store as reserves, which might mean that they have extra resources for things like flowering, defense chemicals to ward off insects and diseases. The big part of this is that water has to be available for these processes, and I'll talk about that in a few more slides, but in general, all things being equal, this can be a benefit. And we are actually seeing that when we look at tree growth rings, the image to the left, we see that some of our species are indeed growing more, they're putting on more wood because of this lengthened growing season. But this lengthened growing season also affects all the other aspects of life in our forests, including things that eat trees. So insects are one of those, like caterpillars, things like that. We know that with a lengthened growing season, we can see dynamics like more generations are able to happen in a single year for many of these insects. They may be able to get bigger in size and they consume more leaf matter or more wood matter of the tree, so they can cause more damage. And the other concern we have too is the rapid change in our climate could lead to what we call phenological mismatches. So phenology is just a timing of events in nature. And so one of these, like a classic example of this, is that maybe a pollinator pollinates a flower. Here I'm showing a non-tree species, that's a impatiens, but to get the idea, pollinator emerges at a different time than the plant flowers. And so the pollinator is not able to help the plant with pollination because of that timing. And so these are one of the things we're sort of watching and monitoring as we see the climate changing, that there could different aspects of our forests and these processes could change at different rates. We also are worried with this longer growing season, we could see some weird things happening this spring. And one of them is frost damage. So we get trees get a signal, really warm spring, they leaf out earlier. These are photos of sugar maple, which is a species that leaves out very early, but we still might get lethal cold temperatures from a frost. And these are examples from 3 different years of this happening, that the foliage at this stage is really sensitive to cold, and it gets damaged by that frost condition. It's usually very localized. Certain elevational bands might get hit, certain aspects of our state. And the trees can respond. They might re-leaf out, actually. They might use some of their stored sugars and reserves to reflush their leaves, which is a big energy suck for them. So they're using excess energy, and the leaves that they have there, if they don't reflush leaves, they might be deformed, as you can see in that top image. So they might not be the right size, really small. So it might limit their ability to capture and store sunlight and energy and make sugars in the rest of the growing season. And of course, we're worried if these things happen sort of on repeat or in subsequent years, could really be detrimental to the health of these trees. We are also seeing with this increase in annual temperature, milder winters, and this is probably something a lot of you have recognized in the last couple of years. I would say this year is a good example of that. We did have that really brief cold snap, but in general, it's been a pretty mild winter, and that's reflected in the data. In fact, the Northeast is warming, the winter is warming at a faster rate than the rest of the country, as you can see, and winters are warming 2.5 times faster here in Vermont than the annual temperature is increasing. So milder winters are projected to continue in the future. One way we can look at this, again, this is sort of a gardener's term, or if you plant species at your house, different trees and shrubs, we use these plant hardiness zones, and that really describes the expected minimum winter temperature at a location. And this is a map showing sort of like the current, it's a little, it goes to 2009, but the current plant hardiness zone. So most of our state, is in this sort of 4 to 5 range, which can get down to -30, -20. And that really says what plants can survive and persist there need to be able to withstand that cold temperature, which is really limiting to a lot of species. And then we look at the projections. This is a long ways in the future, 2070, but that's a really big increase in the plant hardiness zone. So it's looking at Vermont being, in the 6, 7, 8 range in plant hardiness zones. Maybe some places not even having temperatures below 0. So just in context, those things like southern magnolia are zone 7 plants. Pecan is a zone 7 plant, right? So it could mean that we could plant those species here at the end of the century, the big change. And, even looking at our native species, our climate is really controlled by these minimum temperatures. So species like on the left, American chestnut exists in our state. It existed in bigger amounts back in the early part of the 1900s, was killed by chestnut blight. But as you can see from this little inset map, it was really limited to low elevations, kind of warmer locations. And it's a species that is sensitive to cold. And as we see our climate warming, particularly in the winter, that's the problem for the species. We'll see it maybe be able to persist in more locations throughout the state. And then we get less what we call cold injury or winter injury to plants, which is a phenomenon we see. Different species are affected differently by this, and we will see less of this with continued climate change. But again, we have more things that are affected, not just trees, not just plants, insects and diseases are also affected by this, and also processes that we have in our forests. So one of these are hemlock woolly adelgid is a non-native insect that affects eastern hemlock trees here and other hemlocks, but that's our dominant hemlock tree we have in Vermont. And we know it is really limited to southern parts of Vermont because it is killed by cold temperatures in the winter. So those really cold, -20 days, especially when we have multiple days like that in a row, freeze-thaw cycles, those are lethal to this insect. And it's really kept it in check and hasn't allowed it to spread too much from the southern part of Vermont. We are expecting with warmer winters that this pest will increase and go up north and affect more hemlock trees. And then the other thing we see when we have warmer winters is that we have more rain falling as precipitation rather than as snow. So we could see things like a shorter duration of the snow period, places in our state that just don't have snow, that maybe historically did have snow, less snow depth. And this can have a range of implications in our forests. Snow is really important. It sort of acts as an insulative blanket, protector of our soil. This photo shows sugar maple roots, very fine feeder roots that are responsible for getting nutrients and water from the soil. Sugar maple in particular has very shallow roots. Many tree species do have shallow feeder roots, and these can be impacted by lack of snow. So they actually physically freeze, or the soil freezes and breaks up and can cause damage to the roots, can cause damage to things like mycorrhizal fungi in the soil. And so we can see things like soil erosion or leaching of nutrients from the soil along with damage to the roots. Again, this is something that, in any one year is okay, but if we see this repeatedly over time, could have implications to tree health and forest ecosystems. So in Vermont, as I said, we're very cold limited. We don't have a lot of hot temperatures. And this is reflected in this map showing, the number of hot days above 86. Really, we have very few in our state. Although the projection is that this will increase over time. The real implication of hotter summers is actually not necessarily the heat itself. It's really the combination of heat and lack of water. So warmer air temperatures can hold more water, and we can actually have more drying of surfaces. So this is soil surfaces, leaf surfaces will evaporate and actually reduce the amount of water that's in the soil. So it could cause dry soils and drought stress. And this is one thing, even though we're seeing an increase in precipitation, we do expect more dry soils, more periods of drought that could affect our forests. And, our mature trees are pretty resilient. They have deeper root systems that can tap into water reserves in addition to those, shallow feeder roots I mentioned. But if you think about in this photo, seedlings don't have very deep roots. They're very sensitive to summer conditions when they're germinating and growing and getting established. And so when we do see summer droughts, that's one of our concerns, is the effect that will have on our regenerating age classes in the forest. And certainly just in general, that's a sort of this combination of hot conditions in the summer and coupled with low precipitation, soil drying. We generally see that as a stress, and this is reflected in physiological studies. It's a stress to our sort of cold adapted species here in Vermont, which we have quite a few, and many are iconic. So we can, in Vermont, we're actually very lucky in that we have a lot of species that grow here, and we're sort of at the cusp between these two groups of species. And this is a generalization because a lot of their ranges overlap, but we cluster them into what we call these northern species, and these are species that exist in Vermont, and their ranges exist well up into Canada. And they can exist in many cold places, very resilient to cold temperatures, and they've adapted to those conditions. Then we also have sort of more southern species where their ranges extend more south. We think of these as species in Vermont that exist in warmer locations, maybe south-facing slopes, maybe valley areas. And the expectation with continued climate change is these southern species will do better. And these northern species, we won't lose them completely, but they might be more stressed. They might be more limited in where they can grow. So their range might constrict, and they might be more sensitive to other stressors just because of that continued stress from the climate. And we are seeing, I mentioned in the beginning, we're seeing more overall precipitation. This is, there's not a lot of negative implications to trees and forests. I'll talk about the heavy rainfall events in the next slide, but just in general, total annual precipitation increasing. Great if there's more water availability to trees and plants. That's always a good thing. The one thing we do expect to see more of potentially, depending on these dynamics, is we could see more foliar diseases. So this is when leaf surfaces remain wet for long periods of time. Foliar diseases, fungal pathogens can sort of take advantage of that. And again, these are things that happen naturally. We have a lot of native fungal leaf diseases and pathogens. But if we see repeated events of this, again, it's just sort of a stress to the tree and can weaken it from being able to photosynthesize and thrive. And we are seeing with this increase in precipitation, it's not uniform across the year or across events. We are seeing that we're getting more rain in sort of these punctuated events. So these are, we call heavy rainfall events, heavy precipitation events. Here is showing in a graph the number more than an inch in rainfall, but we're sometimes seeing 2-inch rainfall, 3-inch rainfall events. And what can happen here is the rain can come down so quickly, we can have things like soil erosion, just from the physical nature of that water running off our steep hillsides. It can wash away leaf litter, and again, expose those fine roots I mentioned. That can physically deplete nutrients in the soil. And certainly there's concern about, downstream flooding and effects on water quality here. One of the other things we are anticipating with continued climate change, but it's really hard for us to determine if this is happening just because of lack of data and sort of the infrequency of these events, is that we sort of get more disturbance events. So these are, ice storms, heavy snow that might break branches or bend trees over, windstorms, things like that. It's hard, again, these are usually very localized events, but something we can expect to see more frequently, or maybe they'll be more severe. And for forests, it's not, this is often a very big infrastructure issue for roads and power lines and things like that. For forests, this causes gaps in our canopy, allows forests to progress and change. And so unless we see really catastrophic changes, this is something that can facilitate change in our forests and add to different age classes or diversity in our stands. And so, I sort of outlined a lot of these drivers and impacts. Some of these will benefit certain species or trees, right? Like a longer growing season. I didn't really talk about it, but climate change is caused by more carbon dioxide in the air, amongst other greenhouse gases. Carbon dioxide is what trees and plants use as their food input, with sunlight and with water. And so we are seeing that is a benefit to many of our trees. But then you can see the suite of other changes that we have, other stressors we have in our forests, like deer browse, which often impacts certain species, certain age classes of trees over others. Certainly earthworms we have in many of our soils are having other consequences. And so there's a lot going on in our forests, and we're really trying to disentangle what will be these impacts to certain species, locations now and in the future. And you can see it's quite complex. When we think about trees and forests, they can't get up and move to a new location, right? So they either have to sort of buckle down and adapt to these new changing conditions. Some trees might be able to do that. Some might suffer or perish in that situation, or they can move to new locations through regeneration, through the process of creating seed, having that seed be dispersed to favorable locations, germinate and grow. And a key part of this is there has to be space for these new seeds to grow, to germinate and thrive. And that in a forest takes what we call succession or dynamics, and that creates space for those new trees to grow. So usually a tree or a group of trees die through various causes, and it creates that opportunity for a new age class. And this has happened in the past in our forest, right? Our forests actually haven't been here forever, even though we look at our landscape, our 4.5 million acres of forest, really, really impressive. But it wasn't that long ago that we were covered in ice, quite a lot of it, and we did not have forests here. And these forests, all these species we have here have slowly migrated from the southern United States and different places in Appalachia up to our location. And really, it was 11,000 years ago, we were just starting to see forests come in, and really not even what we would know now of our forest systems with our diversity and different age classes and different sizes of trees and all the species that depend on our forests. But when we look at the pace of change that we're having, so this shows global temperature change over time, and I put this red dotted line to reflect what the last slide I just showed. So that's sort of when our forests were just coming in here in Vermont and New England. And you can see that we've had fairly steady climate since then. There was a cooling of the climate, that what is the direction that we were going to go globally, until we see this anthropogenic climate change that's happening because of increased greenhouse gases in the atmosphere. And just directing you to see how rapid this increase is. And I think this is really important to understand, is this is happening at a rate that is really unprecedented in these forests and these trees. They are able to move around and migrate and adapt to changing conditions, but this speed is asking a lot. And then we also have some effects in our forests that have left a legacy from our land use, our land clearing that we did here in Vermont and the rest of New England for agriculture and development. And it's a really incredible story how resilient our forests are. They really regrew in pretty short amount of time, 100 years. We have now pretty beautiful and amazing forests here. But the thing is that this clearing and some of these practices did leave some issues and degradation in our forests that we can actually address through some of our management decisions. So we see things that we have pretty young forests. Some places we have very few species represented. A good example here is the left photo, sort of these stands of white pine. Those come up on old fields. It's one species. They're usually very close together. Those trees don't have a lot of foliage. They're not thriving. And really it will take some sort of disturbance to knock those trees down and create opportunities for other species to come in and allow that forest to change and have some dynamics moving forward. We also have things like invasive species that limit these dynamics and altered soil processes, things like reduction in deadwood through our forest just because of the young age of our stands. And we do know from research, and Tony will talk about this, and research around the region and from other places, that forests with more species and a range of ages, conditions, including deadwood, standing and down, with irregular gaps in the canopy, we know that those conditions are more resilient to climate change and other stressors. And so we can make decisions when we're thinking about managing our forest. We can make decisions depending on the nature and conditions of that forest stand to increase resilience and adaptation to these changing conditions. And the cool thing is we can do here is we can pair this with locally sourced resources that adds to our community resilience too. Gives us a sense of sovereignty in our material sourcing and our energy and local, rural jobs. And so there's really no one size fits all approach here. There really needs to do site assessment to assess these vulnerabilities because of all these nuances and the past land management decisions. And so assessing the status of the forest and the conditions can help direct management to help advance some of this resilience. I did mention these are some resources I have for landowners. There are also resources for professionals that I have on this site too. Newly launched, very new extension forestry page. I'll be updating it with new things that I create and other folks in the region create. So I'm hoping it's sort of a good landing page and clearinghouse for resources for climate change management and other ecological topics. And here's my email. Please reach out if you have any questions or want to talk, and I will pass the baton off to Tony for his part of the talk.
All right, thanks, Allie. And those that weren't aware that we now have Allie at UVM, you can see why I'm so excited about it. Really appreciate that presentation, Allie, and all you're doing to advance this information. And so what I'm going to do is just kind of keep building upon what Allie was describing, and just maybe somebody give me a thumbs up in the chat if they're seeing the screen okay. And talking about, how do we actually take this information about all these changes and integrate it into kind of on the ground actions. And so I'm going to go through kind of 3 case studies of this work we're doing in Vermont and in New Hampshire, where we're actually kind of implementing things on the ground to try to understand, what does adaptation look like if we're trying to manage for all these stressors and all this uncertainty that Allie was talking about in terms of the future of our forest. So similar to, I think, that key connection to thinking about resilient communities and what's happening in terms of, making sure we have local kind of wood production coming from our landscapes, just so that we are carrying some of our consumptive uses of wood as a state and as a region. Another thing that we don't emphasize enough, and I'm certainly going to jump right into stand level management and how we do those things to increase resilience, is that if we lose forest, we've kind of lost the opportunity for resilience. And I think, as we look at Vermont currently, look at the region over the last 10 years, we've been losing forest land at a very significant rate. And so the first step to any adaptation is making sure that we are protecting forest land and preventing it from being developed and converted to non-forest land. So I think a lot of our emphasis right now, and even the comment in the chat, is on how public lands are being managed. Those are conserved and protected lands. And really a key concern is that we're losing lots of private land to development, and whether that's individual houses in a lot of our ski towns or clearing for development, we need places to live. But if we want to have resilient and connected forest landscapes into the future, we need to make sure that our private lands are being conserved and we're putting in those proper protections. So last, I'll speak to that, but just, this is often overlooked, especially now that I'm going to jump right into thinking more about what we can do at the property level, stand level, and look at ways to maybe manage for more adaptation. So Ali really set this up well in terms of talking about our current forests and their condition, and really we have very simplified forests in general. That's been a product of our historic land use. And that really presents some challenges in terms of just the potential for that forest to adapt and respond to climate change. And so if nothing else that you get from this part of the presentation, really it's all about complexity, trying to find ways to increase the complexity of the forest, both in terms of the structures, so the diversity of tree sizes, the amount of dead wood, the age classes, but also the composition, so the species present, kind of their representation and what that looks like in space and time. And so really what you're trying to do with adaptation is that we know we can't keep Vermont's forests looking like the forest of 1980. We can't keep the forest looking like the forests of the year 2023. What we're trying to do instead is keep those forests operating within a realm of what we view as acceptable conditions in terms of delivering us the goods and services like water filtration, carbon storage, local wood products, aesthetics that we really expect from forests. So what this diagram is showing is we have two different scenarios here. So we have one forest that's very simple. So picture this is just a very, very simple northern hardwood forest. And once that forest is disturbed, it really has only a few ways in which it might respond to that disturbance, given its simplicity. So these are adaptation pathways, how that forest is responding to disturbance. And really only a couple of those pathways stay within kind of the bounds of what we view as acceptable forest conditions. So they still are producing kind of the values that we demand and are hoping for from our forest. On the right, we have a forest that's complex. It's got a lot of diversity and structure, composition, functional conditions. And so when that forest is disturbed or impacted by climate change, there are many different ways that forest can respond given that complexity. And many of those pathways, those adaptive pathways, so that response to climate change, are staying within this realm of conditions that we are expecting from that forest into the future. And so forests without us around are going to adapt and respond, but we have expectations from a societal standpoint around what forests should look like, what they should provide in terms of different values. And so much what we're trying to do is to find ways to increase the opportunities for that adaptation within that realm. In addition, as Ali was mentioning, there are a lot of things that affect either individual species uniquely, like hemlock woolly adelgid, threatening hemlock, emerald ash borer, threatening ash, Asian longhorn beetle, threatening our maple species. I need to keep this talk within 20 minutes or so, but I could go for another 20 minutes on just what's threatening our species. But all of those are going to have the potential to eliminate a species from our forests, whether it's because of climate stress or because of an insect or disease. And so when we're looking at managing for adaptation, we're not just looking at sustaining certain species. Importantly, we're looking at trying to sustain the functions that our species provide. And what I mean by that is I have a diagram here in the upper panel that's a mixed wood forest that has one conifer species, so let's just say it's balsam fir, and one hardwood species, let's just say it's aspen. And so if some sort of insect or disease comes in this forest and eliminates the balsam fir, we've essentially lost the function that conifer species provided that forest. There's really not any redundancy or another conifer species present that can replace that function. Whereas in the picture down below, we have 3 different hardwood species, 2 different conifer species. So there's a lot of redundancy in that function provided by the leaf habit of these trees. And so if one of those species is eliminated, we still are sustaining some of those functions into the future. This doesn't certainly get at, there are cultural values tied to specific species that can't be replaced, But in general, we're trying to at least sustain kind of ecological values into the future by having that redundancy in our forests, so having a complexity of species present. So what that means is that when we look at our forests and think about, what species might I encourage through management, or what species might I be interested in going forward, or how do I evaluate my forest through a different lens? A lot of what we do now from the perspective of vulnerability and trying to sustain those functions is looking at the different trees in the forest and trying to see how many of them serve a similar function. How many of them provide the same type of habitat to different species, or how many have similar quality of leaf litter that they're producing. Likewise, are there similar cultural values, so that if one species is lost from an ecosystem, we still have some of those values being sustained by others. And then finally, and Ali brought this up, several times, we know climate's changing. We know even just the suitability of growing conditions are changing. And so what species in that forest are actually adapted to these future climate conditions? And if no species present are actually expected to do well in the future, do I do things like actually think about planting or seeding species that might be adapted to future climate? And I'll certainly talk about that quite a bit on the work that we're doing. So what I'm going to do is just present 3 case studies briefly of some work that's happening in partnership with a diversity of partners from the state of Vermont, Asia Conservancy and Vermont Land Trust, U.S. Fish and Wildlife Service, and Dartmouth College, and looking at how do we actually take these kind of challenges facing our forests and actually develop management strategies on the ground that might be ways to keep that forest within that realm of conditions we're hoping for in the future. And so all of these build from what's known as a climate change response framework. I'll kind of go through the main pieces of that in a second. But the idea, as Ali was mentioning at the end of her presentation, is to localize these threats, but also localize solutions to specific forests that really account for both that underlying ecology, that underlying land use history, as well as what people's goals and objectives are for the site. And so I'll go through each of these, give you a little bit of kind of background on the actual management happening there, just to give you an idea of what adaptation looks like in practice, and share some results in terms of what we're seeing kind of as early results from these areas, particularly as it relates to how some trees we're planting are doing. So as I mentioned, this work really builds from what's known as the climate change response framework. This was first kind of introduced in 2008, and then has really been codified into what the Northern Institute of Applied Climate Science uses for kind of training and kind of trying to get managers and others to think about integrating climate change adaptation into their management. And so essentially, this really takes a spectrum of approaches to how do we think about forests and managing them into the future to deal with all those changes and importantly, the uncertainty that Ali was talking about in her presentation. And so beginning kind of from the first end of the spectrum of what we might do, we might decide, going forward, we're going to try to do actions in our forest that resist change. And so we're really trying to manage that forest to improve the vigor, kind of resist any, invasive species that are trying to come into that forest, and to the best of our ability, do all we can do to keep that forest kind of as it currently is. I often do this, and others do, as a near-term strategy, because as climate continues to change, our ability to keep forests, as they are today, gets harder and harder. And so often this is kind of fighting against general ecological momentum of the ecosystem. Moving down the spectrum, we have strategies that we call resilience strategies. So instead of trying to keep that forest the same, this really builds off of that diagram I introduced, where we're trying to kind of build in mechanisms for recovery, complexity into that ecosystem, so that when it's impacted by disturbance, impacted by climate, it's able to recover back or kind of adapt along pathways that we view as still acceptable and kind of consistent with kind of our historic understanding of that ecosystem. And so this diagram shows that over time, this ecosystem is responding to change, but it's bouncing back towards a condition that we might view as still a desirable state. And then finally, the last option is we can transition our forest. And so we know change is coming, it already is happening. Do we start actually doing deliberate actions in the land that start introducing species or creating structures that might be better adapted to what we might see in the future? And so deliberately transitioning to that future. And as you can expect, most of our management experience is not about managing for 50 years from now. Our management experience is what the last 50 years has been. And so the more and more we kind of manage for the future, the greater our uncertainty is about kind of how we actually approach that management, which is why we're excited to be doing a lot of this research. For those that have heard other frameworks, there's also the RAD framework, Resist, Accept, Direct framework. And so the resist strategies kind of overlap with what I just described for resistance and resilience. And the direct strategies overlap with what we call transition. So I'm going to talk first about a large-scale study in New Hampshire. Again, I'll go through these briefly and just highlight some basic kind of outcomes so you can at least see what this looks like on the ground if we were to manage for this complexity and think about adaptation. So this experiment is part of what's known as the Adaptive Silviculture for Climate Change experiment. It's large scale. It's over 400 acres in northern New Hampshire in partnership with Dartmouth College on their land base. And this is an experiment where we actually are testing, like, what does resistance look like on the ground? What does resilience look like on the ground? What does transition look like on the ground? And importantly, what does accepting look like on the ground? So doing nothing. And so what I'll do is just talk briefly about what that looks like in kind of forester speak. So what do the treatments look like on the ground? And then share with you just some of the outcomes, because people are always interested, certainly in how are the trees doing and what's happening on the landscape. So these are the three treatments that are occurring. And so these were developed by foresters, hydrologists, wildlife biologists, and scientists kind of locally for the site. And so it ranges from, these are rich northern hardwood forests. So the resistance in this forest is basically, doing single tree selection. So, and I'll show some maps of this in a second, where you're largely trying to maintain that forest as it currently is, increasing the representation of sugar maple, maintaining that multi-cohort structure. But as Ali brought up, by thinning that forest, we're increasing, the vigor of some of the remaining trees. So we're reducing impacts of drought. We can do tree level selection. So maybe selecting trees that might have more resistant crown forms to ice loading, selecting beech that might show resistance to beech bark disease, but really trying to keep that forest as it currently is. Moving down the line here, resilience. So here, still using multi-age silvicultural methods, but in this case, actually introducing some larger groups. So that we can actually try to recruit kind of the diversity of tree species, so kind of increasing that compositional complexity, while also, maintaining some areas as high density areas to give you kind of a range of responses in that forest. And then finally, transition, still in the multi-age category of silviculture, but now creating even larger openings. And within those openings, something I'll talk about in a second, is planting different tree species that might be better adapted for the future. And so of all these treatments, really only the transition treatment is one in which there's some thinking going into possibly adding species to that landscape that aren't currently present in the name of climate. So if we were to go into that forest and look at a 2.5 acre area and evaluate like the locations of trees, so if we mapped all the stem locations, this is what those different treatments would look like. And so on the left, this is the unmanaged control areas. And so each one of these dots is a tree. So this is, you can see that's a high density condition, pretty uniform in terms of the light conditions, right? Really, it's only going to favor shade tolerant tree species, and likewise only favor wildlife species that are interior species. Moving down the line to resistance, still a high density condition, but you can see it's a little bit less dense than the control. So a little bit more resource availability for residual trees, but still favoring primarily shade tolerant trees. And then resilience, you can see these canopy gaps. So we now have areas with more light to allow new tree species to establish, but we also have areas that are high density. So we have kind of that range of responses, that increasing complexity. And likewise, same with transition. So kind of larger openings mixed with high density areas. And so the reason I'm showing these maps is just to give you a feel for, for very quickly, you can have strong influence on just the level of complexity that might exist with, as we move down the spectrum, greater complexity with those resilience and transition approaches. So most people don't get excited about STEM maps. They mostly want to know, like, well, what's it like to plant and how do they go? And so I'm going to give 3 examples of planting over the next 10 minutes or so as I go through the presentation. And the key thing is to pay attention to the conditions that we planted in. And so this experiment we planted in 2018. This map is showing the precipitation conditions during May. So when the trees went in the ground, and then once they were in the ground, the level of rain they experienced, which, as Ali pointed out, was well below average. So the rule of thumb for any planting is, number 1, expect the unexpected, and number 2, if I'm planting, you shouldn't, because we've had really bad luck. So you'll see that more clearly in a moment. So what are we planting? Ali, talked about this, but thinking a little bit about how tree species have historically moved across the landscape in response to climate, as well as thinking through what species might provide some of those functions of trees that could be lost via climate change. And so in this experiment, we're planting 9 different species. And essentially, those represent a range of what we'd call assisted population enrichment. And so what that means is, if we look at this diagram here, here's the current range of a species. And all we're doing is kind of increasing the representation of that species within the area that we're planting. So we're not moving it outside of its range. We're just increasing its representation where we are, given it's expected to do well under future climate. And then 3 of these species are what we call assisted range expansion. And so we are actually moving species to the north of where they currently exist, and really basically moving them to where we would expect them to be if they could actually move as fast as climate was changing, right? Trees just cannot move as fast as this change. So what have we seen after 5 years of looking at these over 5,000 seedlings across this site? Generally, what we're looking at here is the survival, and this actually also includes 2 spots in Vermont we planted the same year. And the bottom part is growth, and so it's for the 9 different species. And so what we saw is a pretty classic trade-off where the species that had really high levels of survival, so things like white pine, red spruce, red oak, generally did not grow as fast as the species that had low levels of survival, like aspen, but they grew really quickly. And so if we combine those results, generally what we see are kind of the top 3 tiers of species that we've planted are white pine, which both survived well and also grew rapidly, red spruce, big-tooth aspen, red oak, and eastern hemlock. And all of these species are ones that are already currently found in this landscape, and all we're doing is increasing their representation via planting, doing what we call population enrichment. So another example to look at beyond that work in New Hampshire, in Vermont, so getting on the other side of the river, onto the even better soils, where beyond looking at climate change, as Ali mentioned, there are all these other changes. And so we're thinking as well about how do we deal with emerald ash borer and its potential impacts on rich northern hardwood forests, where ash is such a big component of those. So what we've been doing in this location, again, in partnership with Dartmouth, is evaluating both what happens when we don't do anything. So, as a forest gets impacted by EAB, how does it change? Also, what happens when people would blindly just cut all the ash, which we're not recommending, but that's happening. So we want to see what the response is. And then importantly, how would we actually manage that forest adaptively into the future? And that's the treatment I'll talk about. So the adaptive approach to emerald ash borer on this rich northern hardwood site, again, to Ali's point, creating these gaps, those openings in the canopy that provide opportunity for new cohorts, new species to establish, but at the same time, doing things like resistance type approaches in between those gaps where we're actually thinning that forest, trying to increase the resources left for trees, also trying to increase the vigor of the trees that are remaining, and doing that in a way that actually tries to keep ash as part of that future forest. I'm a big proponent for trying to find ways to keep ash out there, not just cutting it all. But there is a component of this that also is planting some additional species that aren't currently present on the site, trying to actually diversify that forest while also doing things like increasing the amount of dead wood out there in the landscape. So, as I mentioned already, if you hear through the grapevine that I'm planting trees, you shouldn't, because we planted this site in the year 2021. Those that remember that year, spring came, seems like April 1st. It was extremely hot. This is a map of like how warm it was relative to average conditions that year. And so we planted this site in mid-April. We were fortunate. We'd ordered all our seedlings early. And what we also were fortunate for is that despite much of New England being in kind of dry conditions, both Orange County as well as parts of Western Vermont did get a little bit of rain during that time period. So it really did a lot to help these seedlings do well on the ground. And what we've generally seen on this site is very high level of survival. That rain was really critical. Getting those trees in the ground early, almost critical. And also the 6 species you're seeing here, 4 of these are currently present on site. So we call it assisted population expansion. Basswood, red oak, black cherry, and bitternut hickory, and those are all doing quite well. Whereas American chestnut and black birch also doing fairly well, but not as well. Those would be examples of what we call assisted population, assisted range expansion. And so just pointing to some of those challenges that Ali brought up, that you still are going to have frosts and other things that might limit the survival of some of these more southerly species currently. So on the ground, what does that look like as it relates to some of these goals for adaptation? So by creating kind of gaps and thinned areas and unthinned areas, we've increased the complexity of that forest, certainly created a range of resource environments and pathways for that forest to respond. Certainly by planting additional species out there, there's now many more potential responses to climate beyond what was currently present on site in any abundance. And we've also certainly increased the representation of species that emerald ash borer won't kill. So having non-ash tree species out there. But at the same time, not forgetting that we still want ash as part of our forest. And so leaving behind future options for ash is pretty critical. So the last thing I'll mention very briefly is a little bit different scenario. So moving out of northern hardwoods, but into a very simplified spruce fir forest. We've also been working in partnership with the U.S. Fish and Wildlife Service in the Nolhegan Basin. Those of you familiar with that landscape and its history, prior to it becoming part of the U.S. Fish and Wildlife Service land base, it was industrial timberland, and so it had a real history of like emphasis on conifers and emphasis on kind of growing them primarily for fiber. And so this picture below, as well as the one next to it, these both are what the forest looked like prior to us working there. And so, as Ali was mentioning, simplified forest, high vulnerability. This is about as vulnerable as you could get. All one species, all one age class. In this case, it's balsam fir, a species that we know is really not projected to do well in the future in our forest. So all I'm going to do to kind of talk about that complexity piece of the stand scale is just show you one of the treatments and then highlight seedling response before wrapping this up. And so what you're looking at here is one of the ways that we're thinking about increasing complexity very quickly in a very simplified forest. So again, just to remind you, this is what that forest looked like prior to any management. And so this 15-acre area is receiving what we call a variable density thinning. And so it's a way to really introduce a lot of heterogeneity and structural conditions into a forest that's been highly homogenized quite rapidly. And so what it entails is really doing a combination of three things. One is leaving things behind, so having these small patches that are really meant to serve as kind of microrefugia for species that might need deep shade or might need cooler climates. At the same time, we have areas that are being created as gaps to kind of create those opportunities for new age classes, for planting. Then in between those areas, we have the forest being thinned to really accelerate kind of large tree growth, kind of increase the representation of understory development in those areas. So really all doing three things within a small area to try to accelerate that complexity. So as I mentioned, don't plant when I plant. Last May, we planted. Another awful year to plant. So I think that the key takeaway really is if you're going to plant trees in Vermont, expect the unexpected in terms of weather conditions, get your seedlings as quickly as possible, and get them out there when you can. But we did. We planted over 11,000 seedlings, so it was huge scale for Vermont standards, puny for industrial scales, and I think that really had a big impact on what we're seeing in terms of survival. And so in this work, our initial survival hasn't been great. We planted only conifers, so trying to restore some of those signature conifers to this landscape, and in particular, ones that are expected to do better in the future. So overall, less than 70% survival. We saw far higher survival in our small gaps. There was some planting happening in larger openings that was not as high. But of particular note, red spruce didn't do as well, which is in contrast to other places. And essentially what we did, even though we protected half the seedlings, is we introduced a food source that the snowshoe hare are really excited to see again in the landscape. And so we had pretty heavy herbivory by snowshoe hare on the red spruce that really impacted survival. So certainly not great. So what we're seeing just overall is that, as Ali mentioned, we see these projections for future change. And so oftentimes we're planting for that future condition, but we're still getting things like late season frosts and certainly like really cold temperatures, maybe be for a couple of days, but that's all it takes for, either lethal temperatures or at least killing parts of some of these tree species that are adapted to further southern climates. And so overall, what we're seeing is most of those species we're planting that represent that assisted population enrichment are doing much, much better overall than ones that are more of a movement forward. I will point out that we still are seeing high levels of survival on those ones that are being moved forward. So it suggests that we should be including that as part of the portfolio of things we're trying. But definitely there's some risks with that you're bearing. So just to reemphasize what Ali said, I think the beauty of this is I think there's no cookbook. It's a challenge, but I think the beauty is it allows us to be creative. Any given forest is different from the next given forest, and so localizing adaptation strategies both to the ecology, but also your objectives is really important. And as much as people get excited about trees being planted, it's a small part of what we're really trying to do here. And some of the ideas that Ali mentioned, like increasing complexity, more dead wood, more age classes, more species diversity, all of those things that are consistent with how we've thought about ecological forestry and other stewardship are really important and even more powerful now in the context of climate change. And the last piece, I think, just going back to how I started, we need to be both conserving forest lands, so not allowing us to lose forests. That really should be like a consensus across all groups interested in the forest in Vermont. That should be priority one. Let's not lose any more forest land. At the same time, when we're managing forest land, thinking about ways to restore complexity, and as well as what Ali said, keep kind of local wood as a part of what we consume as a region, and certainly keep those rural communities going. So I'll acknowledge a bunch of folks that have been helpful with this, and then I think both Ali and I can take questions.
I think we got a couple of questions in the chat from a while ago. I can read them. So Jeffrey asked, what do our speakers think about the U.S. Forest Service Telegraph Gap project? I'm not sure who that's about.
Yeah, let me stop sharing. Oh, there we go. I'm happy to speak as the telephone gap sale. So yeah, those that are aware, but I guess the first thing I'll say is that it's just I think we shouldn't take for granted that we actually are able to know about that project, given it's public land, and so there's a you know, through the NEPA Forest Planning Acts, you know, the actual opportunity for the public to comment on that and make sure that anything that's happening on that land base, there's feedback on environmental, social, cultural impacts. And I think, you know, those that are familiar with any forest management or any activity on a national forest, it goes through the highest level of review and scrutiny of any like project happening in any forest in Vermont and elsewhere. And so in terms of the details of the project, I think right now they're still sorting out just like, you know, what public comment they're going to integrate. But I guess I would just say broadly, I know there's a lot of focus on public land management in the region. Public land provides 3% of the total volume of wood that Vermont cuts every year. And that 3% volume is really the most scrutinized, evaluated, professionally delivered wood of any land base that we have. And so I think it's great that, you know, we're talking about those areas and there's concern about them. But I think in many cases, we're losing sight of just that we even have the ability to have input on that and have the ability to see just the planning and the level of expertise that goes into any tree being cut in a national forest. And so I think, you know, from my experience with the Green Mountain National Forest, they do tremendous stewardship. There's a lot of thought that goes into it. A lot of our wood comes from places where we don't have any say over what happens there. There's no review for environmental impacts. So I think in the big picture, you know, what they're doing is fantastic. And they're currently in the process for receiving comments on that, which I think, again, we should all be happy. We have places we can comment on and give feedback. But in general, in terms of what they're doing, they are kind of maintaining a diversity of forest conditions that aren't happening in many other parts of Vermont, while at the same time doing it with some pretty tremendous levels of environmental review and oversight and public input. So that's my rambling perspective on it. But I think in the big picture, you know, relative to like the total forest loss happening in other areas, I do wish we would probably channel more of our energy into that right now in terms of just the impacts of what's happening. Not belittling. We should also be commenting on public lands management because that's what we're allowed to do as citizens of the U.S. But I think we also need to be looking at, it hasn't been a good few years in terms of keeping forest in Vermont.
Yeah, just so I can make a few comments after that. I agree with what Tony said. It is great to be involved in our, you know, land decisions and on all of that. And so, you know, don't want to discourage that, but thinking about really, I've been getting, as an ecologist, it's sort of odd, I've been getting more and more into thinking about our wood use and our demands, our resource demands. We're part of the ecosystem. We're not separate from it. And we look at wood use in our state, and in Vermont, we harvest about some work that Tony's working on with some other colleagues, you know, 85% of our wood use. And so, and some of that we're exporting, we're importing, but that's sort of like overall what we're harvesting from the woods versus what we consume from our day-to-day activities, building, all those things. Wood is in a lot of products you don't really recognize it's in sometimes. And then we look at states to the south of us, like Massachusetts, and they are harvesting less than 5% of the wood that they use. And so that wood is coming from elsewhere. We don't see where it's coming from. might be coming from far places. Places that have plantation forestry is pretty common in the southeastern United States, or places like New Zealand. Very fast rotation, not, like in our Vermont forests that we have a lot of family-owned forests that are managed with multiple objectives, multiple uses to try to diversify that structure and function. So it's just a bigger picture and conversation that we need to have, thinking about all these uses. And there are going to be trade-offs and considerations we need to make, but it's not a simple, sort of one answer conversation.
I guess if we're going through the chat, the next question is about ecosystem engineers. So beaver and what they do with forests. Do you want to jump on that? I can say something on that, but yeah.
I think the question is about data, and I'm not, that would be, their beavers are great. I would really encourage folks to read Eager, the book by Ben Goldfarb, I think his name is, but really excellent book about, and there's a few Vermonters that are actually covered and interviewed in that book. And because Vermont has done a lot as far as encouraging beavers in our areas versus some other states that might be still at odds with beavers because of the flooding that they cause. But certainly they create these gaps. They will harvest certain, eat certain species over others. And so it creates some of these dynamics. Then they abandon areas that allow regrowth of forests. So it really does create this mosaic and a lot of dynamics on our forest ecosystem. So yeah, beavers, I'm a big proponent. They also provide, these sources of water and in droughts. And so there's been some examples from places like California where, beaver meadows are the only places that have water in severe drought. And so that's a resource for, animals and insects and all sorts of different parts of the ecosystem.
Yeah, and I guess just to follow on that, I think we have some pretty small population relative to what would have been here, prior to us, extensively trapping them and removing them from the landscape. And so when we think of just the influence they would have had on that heterogeneity, across the landscape of, mosaics of early successional habitat mixed with late successional, when we talk about, what Vermont's landscape should look like, we want to make sure we're including some of those conditions that even though beaver aren't here, there's just the species that depend on them are still here. And so making sure we're maintaining that mosaic is really, really critical.
All right, it looks like next we have a question from Joey about thoughts of balancing the needs of both using forests as a tool for climate mitigation to sequester carbon versus managing forests to adapt to a changing climate. We didn't really touch on carbon. It's stuff that both Tony and I talk about and work on a lot. And you may, many of you are maybe aware about the power of our forests to take in, they absorb carbon dioxide from the atmosphere, just what all trees and plants do. Trees are exceptional at it because they're woody, they're large, they live for a long amount of time, and so they can store quite a lot of carbon. A lot of that carbon actually gets cycled to the soil, and so in our forests, soil actually store more than half of the carbon in our forests. So it's pretty amazing, but that carbon will be in dead wood, in leaves on the ground, cycled through the forest in a lot of different ways. As far as that balance, in our forest landscape here in Vermont, we talked about Green Mountain National Forest land. That's about 10% of our land base. Another 10% is state-owned land. The rest of that is private land. And so in usually fairly, smaller parcels, maybe 50 acres, 100 acres, 300 acres. And so we have this really amazing mosaic because, some people have done different timing of different management. We have sort of things that happen at different rates. The harvest rate in our forests in Vermont is about 1%. And so what we have is that with that, we've been able to extract resources, wood. That wood stores carbon for as long as it's used, which is great. It can even save some other greenhouse gas emissions when that wood's used instead of other products. So specifically steel any plastic-based or fossil fuel-based product. If we can use wood instead of that, concrete, we get additional savings as far as greenhouse gas emissions. And so again, there's a lot of accounting that goes into this, but thinking about a landscape level perspective of having forests in different states, having, harvesting different areas of our state at different times gives us a lot of that, where our forests are doing a lot, offsetting about 50% of our state's greenhouse gas emissions right now. And so those are emissions that we release from heating our homes and buildings and driving our cars and other, sort of industrial processes in our state. And so, when we think in the future, we want what I call resilient forest carbon. So we want carbon to be stored in our forest, but to continue to be sequestered. And so when we have situations like I showed that photo of the old field white pine, that's one species, or Tony showed the example from the Mohegan, that's balsam fir, that's very sensitive to climate. That's not really resilient carbon, because we could have one event that comes through those forests and levels those trees, and there's not the diversity and structure. There might not be the young trees to take over when those overstory trees are gone. And so, adding some resilience through management and different decisions we can make can set that forest up to have better long-term carbon mitigation ability for us. So I think, again, there's a lot of trade-offs and considerations. It's not a simple answer, and thinking about our resource needs and whether we're pushing some of those needs elsewhere. Those carbon implications will happen if we harvest trees here or if we harvest them elsewhere. We just don't see that implication. So we have to think about sort of the atmospheric effect of those choices.
Well put. Just to keep us moving along here, the next one relates very strongly to that carbon benefit of forests, about deforestation. So where is this happening? For what purposes? Their attention in the legislature. So the purpose is there's several. One is new homes, new businesses, new solar arrays. So really just clearing primarily for development. So this is permanent. This we call this hard conversion. So I think that oftentimes like deforestation, people talk about just harvesting a forest that stays forest as deforestation. That's not deforestation. It's still staying forest. So this is actually true conversion. And so basically when we're looking at where it's happening, I think historically people would have pointed to Chittenden County, Upper Connecticut Valley, but those of us that have driven around a lot the past few years, it's also, Essex County and Lamoille County, and really those that have paid attention to real estate transfers, the amount of development, the number of new Vermonters that have moved up here in response to kind of the ability to work remotely, and also in response to Vermont being a great place to live. Over 4,000 new residents that have bought new homes, oftentimes punching into mountainsides, other places. And so it's not been just affordable housing. And to be honest, there's not a lot of affordable housing. It's been, more development and perforation of that landscape. And so Allie did a lot of great summary work for the state that kind of looks at the trends, and on average is 4,000 to 5,000 acres per year being lost to development. And that was based on pre-COVID numbers. The post-COVID numbers, they haven't come out yet, but many of us expect them to look even worse in terms of just the rate of forest loss in Vermont. For a long time, there's been discussion about amending Act 250 to try to maintain large forest blocks, kind of prevent that type of perforation where someone can put one house in the middle of one large area of forest. It really impacts that connectedness and ecological integrity. And those that have been paying attention to some of the discussions, does not seem to be getting much traction, at least as part of the conversations. Again, it's tricky, right? We need affordable housing in Vermont. We don't want to have a lot of barriers to that, but a lot of this new development has not been that, at least just from what has been observed. And so it's real. It's unfortunate because it's so much of what provides the benefits we have in Vermont. But there has been discussions. Certainly, there's a lot of effort afoot from folks within the legislature, as well as folks with the Vermont Natural Resources Council, others that are trying to do something about this. But it seems to kind of hit up against that conundrum of we need more housing. We don't want to have too many barriers. We already have enough barriers in place. Why, so it's a tricky one, but pay attention to it, because I feel like does not get enough emphasis right now, given so much has like zoomed in on state lands, federal lands in the state and how they're managed. Those are going to stay forested, thank goodness. It's really the other areas that we're worried about losing.
Yeah, and just, to the carbon question, from a carbon perspective, when we lose an acre of forest land, we lose the stored carbon, everything above ground, and often that soil gets impacted. So we lose some of the storage of carbon in the soil, but then that acre of forest land does not help with future sequestration. So it's sort of taken out, and every acre we lose chips away at that potential for our forests in our state to help, mitigate climate change and offset our own emissions. And so it is really, it's, as Tony says, it's permanent. Back in the, 1800s, we had, conversion to agriculture and it reverted, but when we have buildings on this in these forests, they're not going to revert anytime soon. And so it is a big concern a lot of us share. Yep, and there's a comment just about, it happening in Massachusetts. And I think, it's one thing, TBD, but I'm looking into it. It is hard to sort of look at it with the data. Our data sort of lagged behind, so looking at it in real time, but it will be interesting to see how COVID has changed some of those rates and patterns. I think we all feel like it's changed and we have some anecdotal evidence, but looking at some of the satellite imagery we can use to sort of track where that's happening will be, I think, helpful.
I think that was our last question in the chat. Thank you guys for sticking around to answer everything. If no one else has any questions or comments, I think we're gonna end for today. Thank you all for coming.
Yeah, thanks everybody.
Thanks.
Bye.
Bye.
Thank you.